Hello students, welcome back to my channel. The topic for this video is coagulation or precipitation of colloids, which can also be called as HARDY Schulze rule, because the HARDY Schulze rule comes under coagulation or precipitation of colloids, students. Okay, so colloids is in general chemistry of B.Sc Second year general chemistry, students. Fine. So I want to explain HARDY Schulze rule, which is a very important question from colloids. Those who are watching for the first time, students, I request you to subscribe the channel, like the video, and also please share with your friends. Are you all ready, students? Okay. Without any delay, we will try to understand what this coagulation or precipitation of colloids is. In a colloidal solution, students, the salt particles are away from each other. Why they are away from each other? Or the distance between the salt particles will be high. Why? What is the reason? Because of the repulsions between the same charges present on salt particles. Because of this reason, the salt particles, if we observe in a colloidal solution, they are far away from each other. Suppose if we add an electrolyte containing opposite charges to that particle in excess. Okay, what are we doing, students? Suppose if we add an electrolyte containing opposite charges to that particle in excess, then what happens? The colloidal solution will be neutralized. Okay, so at this point you all know colloidal solution will be neutralized. That means what happens? Here we have seen they are far away from one another. When you are adding an electrolyte containing opposite charges, the particles come closer, and because they come close, finally gets precipitated. Okay, students, previously the salt particles are away from one another. Why? Because of the repulsive forces between the same charges. Now you are adding an electrolyte containing opposite charges in excess. Then the colloidal solution is neutralized. That means the particles will be coming closer. They move close to one another, and finally we see that they get precipitated. Now, thus the process of precipitating a colloidal solution by the addition of an electrolyte containing ions with opposite charge to that of colloidal particles, this phenomenon we call it as coagulation or precipitation, students. Okay, can you see, ma? Yes. Thus the process of precipitating colloidal solution by the addition of electrolyte, what all I explained here, okay, we are putting in the form of a statement here, and we are defining it as, we are calling it as coagulation. The process of precipitating colloidal solution by the addition of an electrolyte containing ions with opposite charge to that of colloidal particles is called coagulation. Okay, students, understood? Next point, students. Even though smaller amounts of electrolyte are sufficient for the stability of a sol, only larger amounts can cause precipitation or flocculation. Why? Because the colloidal particles attract or take up oppositely charged ions from the electrolytes that are being added, by which the charge on salt particles will be neutralized and thus get precipitated. Okay, so generally, students, electrolyte, suppose you add smaller amounts, then the salt will be stabilized, but large amount when you add only, it causes precipitation. Why? Because the colloidal particles, they attract or they take up the ions with opposite charges from the electrolytes that are being added, by which the charge on salt particles will be neutralized and finally gets precipitated. Now, the ion which is carrying the opposite charge, which brings about coagulation or precipitation is called flocculating ion or flocculation ion. Okay, the ion having opposite charge which brings about coagulation is called as flocculating ion or flocculation ion. And also now the coagulation capacity of an electrolyte depends on a factor. What is that factor? It is the valency of flocculating ion, students. This you should remember. The coagulation capacity of an electrolyte depends on the valency of flocculating ion. Okay, so what is flocculating ion? The ion having opposite charge which is bringing about coagulation is called flocculating ion. So valency of flocculating ion influences coagulation capacity of an electrolyte. Now greater the valency of flocculating ion, greater will be the power of coagulation. Greater the valency of flocculation ion, higher is its power of causing coagulation. This is known as HARDY Schulze rule, students. Here comes HARDY Schulze rule. So when you are asked the question HARDY Schulze rule, all the points whatever I explained above you should write. Okay, then you can state this HARDY Schulze rule, students. What is HARDY Schulze rule, ma? The coagulation capacity of an electrolyte depends on valency of the flocculation ion. This you should mention. And greater the valency of flocculation ion, higher will be the power to cause coagulation. This is known as HARDY Schulze rule, students. Okay. Next, let us see some examples for this coagulation. Example number 1, students. BaCl2 or Al2SO4 thrice coagulates negative As2S3 sol. Okay. What is that, ma? BaCl2 or Al2SO4 thrice coagulates negative As2S3 sol. So this As2S3 sol is negative. So when you are adding BaCl2 or Al2SO4 thrice, they are able to coagulate this negative sol. So Ba plus 2 ions can neutralize the positive charge on negative charge on sol particles. This is right change, students. This is negative charge. Okay, students. Here Ba plus 2 ions neutralize the negative charge on the sol particles. Next, example 2. BaCl2 can also coagulate positive FeOH thrice sol. Okay. So here you have seen BaCl2 coagulating negative As2S3 sol. Ba plus 2 ions neutralizes the negative charge. And also BaCl2 coagulates positive FeOH thrice sol. Then, what are those ions which can neutralize the positive charge on sol particles? Yes, Cl minus ions neutralize the positive charge on the sol particles. Okay, students, the same BaCl2 is able to coagulate negative As2S3 sol. So, when you are adding BaCl2 to negative As2S3, Ba plus 2 ions will be neutralizing the negative charge. When you add BaCl2 to positive FeOH thrice sol, Cl minus ions will be neutralizing the positive charge on sol particles. Okay. Now, in precipitating negative As2S3 sol, the coagulation capacity of Na plus, Mg plus 2 and Al plus 3 is of the order Al plus 3 greater than Mg plus 2 greater than Na plus. Okay, students. So, Al plus 3 is first, next Mg plus 2, next Na plus. So, when we can find this, where we can find this order? In the precipitation of negative As2S3 sol particles, the coagulation capacity will be like this, students. So, when you are asked the question HARDY Schulze rule, you have to write all these points, ma. Okay, these are sufficient for your exam. So kindly take the screenshots, or if you have time, please write down all the points in your notebook and prepare well for your exam, students. Meet you in the next video with a new topic. Take care. Bye-bye, students.